हेलो, बात करें। हेलो 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 हेलो। हेलो हेलो हेलो।
Technological University. He has completed his MTech in 2009 and PhD in Chemical Engineering 2014 from the Institute of Chemical Technology, Mumbai. During his PhD, he also completed a part-time postgraduate diploma in Chemical Technology Management in 2013. In May 2014, he joined Gujarat Fluorochemicals Limited, Gujarat as a assistant manager, process engineer and scale-up, gaining extensive industrial experience through three projects from conception of commercial scale and four laboratory scale projects. He has played a key role in technology transfer and commissioning of a multi-purpose production plant. In May 2019, he became Assistant Professor of Chemical Engineering at Lakshminarayan Innovation Technological University, Nagpur. His research interests include green engineering, process optimization, research kinetics, reactor design, process scale-up, natural product extraction, waste to wealth, AI in chemical engineering, and nanotechnology. He has published 12 SCI research articles, 6 book chapters, and several poster presentations. Now, as a token of respect and appreciation, let's give a warm floral welcome to our esteemed guest. For that, I request our HOD of Civil Department, Mr. Nafiz Sayyed sir, to please welcome our chief guest. Now, I would like to call Dr. Vikesh Lade sir, to deliver his speech on AI green technology. Over to you, sir.
I'm extremely sorry I waited you for so long. I'm Dr. VIKESH recently, your colleague has given an introduction, and the topic for today's discussion is AI for green energy. Frankly speaking, I am not expert in green energy, but this is top of town. And since this is top of town, we need to address those aspects in day-to-day life. And therefore, I took up this challenge as a research problem. And to overview this, today I set up some agenda for discussion which I will be talking about. Introduction, why we need green energy. At the same time, probably everyone of you know what is AI and ML. I did not explain, but satirical thing about it is we know everything about AI ML. We use gadgets and apps developed by AI ML, but, and therefore we should know what is actually happening in the AI and ML for green energy. And we will also talk about how this AI is going to help in various green energy applications. At the same time, when we talk of green energy applications, obviously storage and distribution will also arise. And I will discuss a case study which I developed along with my colleagues for hydrogen storage on metal organic framework. And I have used AI and ML models for prediction of hydrogen uptake onto the metal organic framework. You know, there is crisis of energy everywhere, energy as well as water. This is going to be a major uh, uh, sources where overall world is looking at, and therefore, as a developing country, India needs to also look into the energy, and therefore the energy which is currently what we are generating from fossil fuel, we need to also see alternative sources of energy. And there are various global drivers for changing conventional energy resources or sources to the green energy sources. Obviously, in government as well as global scenario, if you look at, all global companies are sponsoring or funding many of the projects which are developed based on the green energy sources. And corporate are getting various benefits if they use green energy. And therefore, if we see this green energy, now how to integrate green energy in AI and ML. Because per se, we know artificial intelligence is machine that adapts and learn on its own and try to behave or mimic human intelligence, right? And this is going to play a pivotal role in industry 5 and more because everything is going to be atomized. If you look at the scenario, even current scenario, many of the plants are operated, even chemical plants are operated here in India, which are actually plants are based in Europe. So this has uh, come to the level that we can operate remotely operate by predicting how the reactor or equipment is going to perform. So this is the the best part which is happening due to artificial intelligence, and obviously it requires a plenty of data. Data should be organized, well organized, and this data ultimately has to be treated using various models, and these models are nothing but you can say data generated models, and this machine learning, another subset of artificial intelligence is machine learning, which uh, transform the data and past experience by supervised or unsupervised learning to a model which can predict the experiences as well as the data which is going to be there. And this machine learning was well before invented well before in 60s. However, the if you see the trends which are there for research, these are very nuanced. And this there are various types, as I already told you, supervised and unsupervised, as well as reinforcement learning, and wherein data is processed either by supervised or unsupervised or reinforcement learning, and logical models are built up. And these logical models are again then compared with the actual uh, industrial data, and then output is whatever output we get can be utilized. And the supervised learning is nothing but it is uh, already the data you have is already you have tagged with correct output, whereas in unsupervised learning you have raw data, which is probably you cannot put it into the organized manner. However, this unsupervised learning can take the mimic the human brain and learn learn on its own and can predict the outcome. This is where we are striving. AI, that is amalgamation of AI into sustainability, will ultimately use smarter energy as well as it will predict energy efficiency. You will obviously cost will be reduced. If you talk about individual green energy sources, let us talk about solar energy. You can predict and forecast the light pattern, sunlight pattern. At the same time, getting data, original data from the experiment, you can also optimize the channel angle, which will be useful for overall application. At the same time, the maintenance need, how frequently you need to maintain, get predictive maintenance, that also you can predict from the AI model or ML model. When we talk of wind energy, which is one of the green energy sources, from AI you can predict wind speed, which is very crucial for obviously wind energy, turbine performance, at the same time how to integrate this wind energy with the conventional grid. The biomass, which is also one of the green energy, feedstock supply chain, which is very crucial for biomass. At the same time, various processes by which you can gasification and even incineration of biomass, which will give you the energy that has to be also the data can be interpreted. At the same time, hydro and tidal, which is also one of the green form of energy, you can get the flow pattern of tides, and thereby you can uh, support the grid integration for this green energy source. Now, I already told you that uh, as a engineer, and today happens to be Engineers Day, I wish you a very happy Engineers Day. And as a chemical engineer, uh, this is one of the recent development that everyone is looking after hydrogen as a green source of energy, and there are this green source of energy. We have been working all over the world. There has been plenty of research going on hydrogen. It is conventional method of splitting up water. You get oxygen in hydrogen at different electrodes. However, the if you look at the overall expenses which are borne by the processes are very are not profitable. And therefore, there is need to identify which method we should go ahead with for hydrogen manufacturing storage. If we look at the quantum of work which has been done recently, you will find thousands of papers on nanoparticles being used as catalyst for reaction. However, the green, the hydrogen, which is this probably we should not look at. You may be knowing it. The hydrogen, which have the energy content of 120 megajoule per kg of, which is three times more than the gasoline, and there are basically safety aspects which need to be considered, and those are transportation and storage. And this transportation and storage of the hydrogen can be taken care by different ways. And one is the metal organic framework, which happens to absorb hydrogen onto it, and thereby you can transport to other places. Now, what are these metal organic frameworks? These are nothing but a polymeric integrated or coordinated crystalline microporous material, and these are normally synthesized by thermal methods. If you look at the timeline, you will see that these are well known from 80s. However, recently, very high level of research is going on for the hydrogen storage as well as carbon dioxide storage. But one side, when we talk of hydrogen storage, we need to also see that it will have implication on the carbon dioxide. Obviously, we will have less footprint for carbon dioxide, and therefore, the metal organic framework, if you see, there is one metal center and ligand, which is nothing but the polymeric chain. However, this metal center can be based on various different metal oxides or cyanides, and various forms of those in coordinated chemistry. And these ligands are also have various types. Benzoic acid you can use, carboxylic acid, tricarboxylic acid. These are ligands, and these both metal ions and ligands are mixed. It does not seem so simple as it looks, uh, but there is there are a number of steps which need to be ensured that you get metal organic framework. If you look at area wise, the BET surface area of zeolite, if you compare with the MOF has 7 times greater area, that is 7,000 per 7,000 meter per gram. So look at the quantum of area which is available for adsorption. So this is equivalent to football stadium. And looking at this area, this have plenty of application. MOF is fine to have application in heterogeneous catalysis, electrocatalysis, sensors, conductors, and the MOF. If you look, there can be multiple combination of ligand, then metal ions. So for all this, you cannot perform experiments, right? And therefore, it can be addressed by artificial intelligence and machine learning approaches. And we have identified the objective of studies as to explore various ML algorithms for the available data sets which are already available onto the various data bank, and the experimental data sets which are available in open literature. Those data sets can be used for developing ML models, and this is done by training and testing models. However, the available models for machine learning are n number of models are there, but training of the data is done and then testing of the data, and this is done with 70-30 ratio. And after training and testing, the data, the model which we get for the machine learning is cross-validated, and the tuning is also done for hyperparameters, the parameters which are actually responsible or major impact on the selection of the MOF. So those parameters will be selected, and this total models or algorithms based on regression, then decision tree, and boosting and neural network. This probably, we have already crossed the time, so I rush through this slides. K nearest neighbor, these are also algorithms, and decision tree, which is nothing but you have a root node, and based on this, if this happens, one root is saying that this node is true or false, and based on that you can select the decision. And then these are example of decision tree. There are random forest, boosting algorithm, and boosting algorithm, normal boosting, as well as we have another extreme gradient boosting. Yes.
सर ये जो रिसेंटली लेक्चर वाला था का सर उन्होंने बताया था कि कैविटेशन होता है करके हमारे केमिकल
यस
तो ये जो आपका एआईएमएल का मॉडल है उसको आइडेंटिफाई कर सकता है क्या कैविटेशन किसका होगा कितना मंथ में होता है करके
जो आपका क्वेश्चन राइट है, इसके लिए एक्सपेरिमेंटल डेटा, क्वांटम ऑफ एक्सपेरिमेंटल डेटा बहुत ज़्यादा है। आप ठीक है, आपके पास एक्सपेरिमेंटल डेटा है कि कैविटेशन, ये लेट अस सपोज यू हैव फ्लो रेट ऑफ 1000 मीटर क्यूब पर हार, पंप में कैविटेशन हो रहा है या आपके वेंचुरी में, बराबर है। अगर वेंचुरी या ओरिफिस है, ओरिफिस में कैविटेशन हो रहा है, उसके लिए आपके पास प्लेंटी ऑफ डेटा रहेगा तो आप मॉडल डेवलप कर पाओगे। और मेरे हिसाब से बहुत सारा डेटा अवेलेबल है। We can use that data to predict whether on that flow rate you will get cavitation or not, provided अगर आपके जो ओरिफिस या वेंचुरी उसके सबके डायमीटर्स भी नॉन चाहिए, बराबर। मल्टीपल होल भी हो सकते हैं, सिंगल होल हो सकता है, तो वो भी जो पैरामीटर्स है, वेरिएबल पैरामीटर्स, उसका डेटा सेट आपके पास होना चाहिए, देन यू कैन प्रिडिक्ट।
तो इन कंडीशन में जैसे कि उन्होंने जीरो वाला से आ रहा है तो मतलब हमारा कैपिटल होता है
बराबर।
तो सर ये तो एआई एमएल में पर अपन कर रहे हैं जैसे एआई को आर्टिफिशियल इंटेलिजेंस डायरेक्टली
बराबर
राइट एआई अपन उसके अंदर अप्लाई करके इसका मतलब ये हो रहा है कि अपना नाम यूज हो रहा है करते
बराबर।
ठीक है तो सर जो कि एआई को हम पता चलता है कि इसमें कितना प्रेशर लगा और कितना टेम्परेचर लग रहा है जो है तो वो बात बता सकता है
आपके पास प्रीवियस डेटा है, देन यू कैन प्रिडिक्ट, बता सकता है।
डेटा होगा
हर हर केस के लिए आपके पास पता नहीं रहेगा ना। आप वो डेटा डायरेक्टली डेटा देखते तो आप आपको समझेगा नहीं। आइदर यू विल मॉडल नॉर्मल मॉडल जो फिजिकल मॉडल होता है, मैथमेटिकल मॉडल डेवलप करते हो बेस्ड ऑन द प्रोसेस एग्जैक्टली व्हाट इज हैपनिंग। अगर आपके पास वो नोन है देन यू कैन टेक प्रेशर बैलेंस, मटेरियल बैलेंस और उसके बेसिस पे आप निकाल सकते हो। बट अगर नहीं है देन जो एक्सपेरिमेंटल डेटा कहीं ना कहीं है आपके पास, हर इसके लिए उसकी एक्यूरेसी, अगर कम डाटा सेट है तो उसकी एक्यूरेसी कम रहेगी। डाटा आपके पास लेट सपोज मैं जिस पे काम किया उसमें लगभग 500 बिलियन डाटा सेट थे। तो कुछ डाटा सेट थे जो एक्सपेरिमेंटल थे, लेट अस सी आल्सो, ये आपकी आर्टिफिशियल न्यूरल नेटवर्क ये है जो सोर्सेस है। हाईमार्क डेटा सेट है उसमें 98,000 डाटा पॉइंट्स है। अब उन्होंने प्रेडिक्ट किया है यूनिवर्सिटी ऑफ ओटावा में 61,000, तो इतने सारे डेटा पॉइंट्स, लेकिन आप अगर देखोगे नीचे ओनली एक्सपेरिमेंटल डेटा सेट कितना है 294 है ना। ये डेटा डेटा सेट्स डेटा पॉइंट्स जो है उसके ऊपर से बाद में जो जिसमें पूरे डेटा नहीं है वो आप उसको नलीफाई करते हो। जिसमें ऑपरेटिंग उसको डिस्क्रिप्टर बोलते हैं। डिस्क्रिप्टर हर डिस्क्रिप्टर होना चाहिए जो वेरिएबल्स है। अगर वेरिएबल्स नहीं है उसको नलीफाई करते हो और देन जो जो अवेलेबल है उसके बेसिस पे आप आगे जाओ। एंड आप ये जो पूरे एल्गोरिथम्स हैं दे आर रेडीली अवेलेबल, उसको अलग से कुछ आपको करना नहीं पड़ता है। इफ यू सी द पाइथन यू विल गेट ऑल द एल्गोरिथम्स को सिर्फ अप्लाई करना है। जैसे एमओएफ के केस में ग्रेविमेट्रिक सरफेस एरिया इज इंपॉर्टेंट, वॉल्यूमेट्रिक सरफेस एरिया, वाइड फ्रैक्शन, पोर वॉल्यूम, जो आपका एमओएफ बनेगा उसका पोर वॉल्यूम, उसमें पोर्स रहते हैं, दे आर वेरी पोरस और उसके वजह से उसमें एब्सॉर्ब होता है। एब्सॉर्प्शन और एब्जॉर्प्शन आर टू डिफरेंट फिनोमेना। एब्सॉर्प्शन आर फिजिकल एब्सॉर्प्शन और एब्जॉर्प्शन जैसे आप स्पंज में पानी जब स्पंज वगैरह करते हो दैट इज एब्सॉर्प्शन और सिर्फ सरफेस फिनोमेना होगा दैट इज एब्सॉर्प्शन। तो एब्सॉर्प्शन इजीली वो रिवर्सिबल है। तो जो हाइड्रोजन आपके सरफेस पे एमओएफ के सरफेस पे है दैट कैन बी डिसॉल्व बाय वेरियस मींस। प्रेशर और टेम्परेचर देके आप उसको डिसॉल्व कर सकते हो और एक्सेल प्लांट में आप यूज कर सकते हो। उसके बेसिस पे इनिशियल स्क्रीनिंग ऑफ द डाटा सेट, जो आउटलायर्स है, जो मैंने बोला कि जो जिसमें पूरे वेरिएबल्स का नहीं है वो आउटलायर्स करके उसको निकाल दो, जो काम के नहीं है, कुछ डाटा सेट नहीं होते उसमें तो वो निकाल दो। देन वेरियस मेथड्स, ये लीनियर रिग्रेशन यूज किया है, लीनियर रिग्रेशन का आपका ये प्लॉट है। देन डिसीजन ट्री, रैंडम फॉरेस्ट, XG boost, normal boost और XG boost is happen to this is neural network। और आप देखोगे which descriptors are important, white fraction, pore volume, gravimetric surface। so most important is white fraction। ये आपको डायरेक्टली डाटा देख के आपको समझिएगा नहीं कि कौन सा इंपॉर्टेंट फैक्टर है, अब इस पे आपको समझ में आ रहा है कि जो प्रोग्रामिंग हुआ, आप जो मॉडल बना उस पर समझ में आ रहा है कि वाइट फ्रैक्शन इंपॉर्टेंट है। अब मुझे देखना पड़ेगा कि जो एक्सपेरिमेंटल जो आपका एमओएफ बनेगा उसमें वाइट फ्रैक्शन ज्यादा है। ओके, तो और जो मैं एक्सपेरिमेंटल सेटअप बनाऊंगा उसमें वाइट फ्रैक्शन ज्यादा क्रिएट करने की कोशिश करना चाहिए, तब जाके वो आपका हाइड्रोजन एब्सॉर्प्शन ज्यादा होगा। ये टेस्ट इसमें भी एचडी बूस्ट इज हैपन टू गेट द मैक्सिमम आर स्क्वायर वैल्यू। सिमिलरली ये एमएल एल्गोरिथम से वेरियस hyperparameter tuning is nothing but optimization of the different parameters। और इसमें आप देखोगे कि KNN tuning का जो parameters है those are optimized and these are this is what exactly you will find in the Python. Obviously, I have done it in Python. So Python में predictive model how you use इसमें प्रोग्रामिंग करनी पड़ती है और you have fetch the available data to Excel में भी आप करके बाद में उसको fetch करना है। Outliers आप remove करते हैं, then ML prediction result by linear regression. However, the use of AI in green energy has various challenges to face. Those are, we need data sets which are reliable. अब आपके पास डाटा सेट भी नहीं है, बहुत कम डाटा सेट है तो आप कंपेयर कैसे करोगे? So those factors has to be taken care. At the same time, scalability and integration. So scale, you are getting data from some small scale, right? Experimental data. And you are directly scaling it up to large scale. For that matter, आप कोई छोटी इंजन है, छोटी इंजन का डाटा है, उसको आप एक्सट्रापोलेट करके डायरेक्टली लार्ज स्केल को करोगे, तो वो एग्जैक्ट प्रेडिक्ट करेगा कि नहीं, वो एक बड़ा इश्यू है। Those are challenges. At the same time, interpretability and transparency. How to interpret it? That is why we need this multidisciplinary approach होना चाहिए। ये ऐसा नहीं कि एज अ मैकेनिकल इंजीनियर इसमें इन्वॉल्वमेंट ऑफ एक्सपर्ट फ्रॉम AI also required to interpret data. At the end, I will conclude this with saying that this AI will help in optimizing the energy transmission at the same time energy generation. May it be any renewable or normal energy sources. At the same time, there should be responsible development and deployment of AI, because if you are using AI directly to nuclear and it happens with some other terrorist organization, that deployment has to be taken care. With this, I thank you. This is my publication out of this, and this was review, and one of the research paper has been communicated to journal. I will be happy to answer any questions. I am extremely sorry I keep you waited for half an hour.